Okay, so 5-2 day 2, we're going to continue to talk about regression and correlation and kind of how your regression line and your correlation line can change given the fact that there's certain points. There's a little bit of notes and then some U-tries. A lot of the stuff I'm going to be manipulating this table. You don't necessarily have to do it yourself. You can just sort of follow along. The point is not the actual scatter plots, is kind of what happens to them as we go along. So here we have the weight in pounds and cost in dollars of 11 stand mixers. So I went ahead and I put those in my calculator in list 1 and list 2. So I'm going to sketch a scatter plot and find the least squares regression line. So I already turned my plot on. So here's what the scatter plot looks like. So you just want to kind of do a sketch. So you kind of got one point down here. And then all the rest of the data is sort of up here. Okay, so now I'm going to find my least squares regression line. So again, I'm going to go to Stat, Calc, number 8, list 1, list 2, calculate. So my least squares regression line is y hat equals negative 20.711 plus 12.53x. And again, let's define our variables. So x is the weight of the stand mixer and y hat is our predicted price. And I'm going to find the correlation coefficient. So r here is 0.7411. And if your r doesn't show up, remember, turn your diagnostics on. So either go to mode or hit second 0. Okay, so here's our original data. So the line's probably going somewhere like that. So starting off kind of at the bottom, it's got a positive, somewhere in the negative. So now, what do you think will happen if we remove the outlier, which is our Walmart brand, so the 830 brand? Sketch a scatter plot of the remaining data and find the least squares regression line in the correlation. So what I'm going to do, I'm going to remove 830. So I'm going to go down to 830. I'm going to delete 830. Again, I'm going to do the scatter plot. So now look at the scatter plot. It's much more focused on that top part. So again, I'm just sketching. Now let's find our least squares regression line and figure out what happens to the y-intercept, the slope, and the r. So I'm going to go Stat Calc number 8 again. So now I have y hat equals 46.59 plus 9.75x. I'm not going to define my variables again because we've done that already. And r is now 0.56. So here's what happened when I removed that outlier. The y-intercept increased. The slope decreased. And we actually want to be a little bit more specific. The y-intercept increased. It actually became positive. The slope decreased. It's closer to 0. Because think about, if the slope of the line is 0, that's probably where you're going to have no correlation. So when we say decrease, we don't mean decreased as in terms of it became negative, but it's getting closer and closer to that 0. And then the last one, r decreased. So the scatter's not as strong. So now what we're going to do, what if that outlier was made of an expensive lightweight alloy, so the observation was really 8700? So now I'm going to go back and I'm going to add in 8700. So instead of 830, I'm going to have 8700. So now look at my data. So all we did was we put 830 back in and we made it 8700. So now you have one dot way in the corner and then your big chunk of dots at the bottom here. So what's probably going to happen is the least squares regression line is going to have to go like this. So instead of being flatter, this line's going to pull it up. So let's see what happens. So now I have y hat equals 455.98 minus 7.18x, and r is now negative 0.303. So the line is really going like this. So let's talk about what happened. So the y-intercept increased a lot, right? It became a lot more positive. The slope became negative, and r became negative. Remember, your slope and your r value should match. So if the slope is negative, r should be negative. If the slope is positive, r should be positive. So obviously this is a special point. So we're going to talk about that in a second. So what if the first mixer in the data set went on clearance for $25? How will this change the regression line? So what I'm going to do is I'm going to change 23,180 and make it 2325. But I'm also going to take that 8,700 and change it back to 830. So I'm going to make that 830. And then 23,180. This is why you don't need to follow along, because it's a lot of manipulations. 2325. Okay. So last one. So now here's what my graph looks like. Oops, I didn't hit zoom 9, I don't think. Yeah, there it is. So you got 2 dots kind of at the bottom, and then a bunch of dots up here. So if I do my linear regression, I have y hat equals negative 20.77 plus 11.86x, and r is 0.609. So really, if you're looking at this from the original, so if we look at from the original, this one, it's pretty much very similar. So all we did was we took this one price, this y, and we made it smaller. So it's really a similar least squares regression line. Not much changed. Okay, so the focus is really to figure out how certain points can influence your least squares regression line. So there's 2 kind of big words you need to know. So any point that stands apart from the others is called an outlier. And you can be an outlier because we have x and y. You can be an outlier in the x or y direction. Now, unlike like chapter 3 and 4, there's no rule for outliers. You just kind of are something different in the pattern. It's not like there's like a rule that you have to figure out. So since the least squares regression line must pass through x bar, y bar, points that are separated in the x direction can be particularly influential. So we call them influential points. So influential points are specifically outliers in the x direction. And it took me a while to figure out what that meant in the x direction. Really what that means is its x value is higher or lower than everybody else. So when an influential point lines up with the rest of the data, such as in number 1, the line won't change very much, but the correlation will be stronger. When an influential point does not line up with the rest of the data, like in number 3, so like up here, this is an influential point in the x direction. Its x is lower than everybody else, but its y, it had a big effect on our correlation in our line. So influential points often do not have large residuals. They pull the line close to them. So I like to think about an influential point as like the one student in the class that like you've always had, or you know, a fellow classmate that's like, if they're gone, it's like the class is just quiet as a mouse because they're so influential on the discussion or just the loudness of the class. So that's kind of what I think about influential points like. So points that are near X bar will usually not be influential, like number 4, because since that point is near all the other X values. So when I changed that 23,180 to 23,25, I just brought this one down. It really didn't change the line because it's closer to all the other X values. So for regression, always graph your data and investigate your outliers. That's kind of like the most the easiest thing I can tell you to do. If you can't graph it, at least think about, okay, if I took this point away, what would change here? Like obviously the line would start to look like this. The correlation would probably be stronger. So on the next page, what I usually have the class do is there's 5 scatter plots, there's 5 correlation coefficients, and 5 lines. Now these don't match. Oh no, they do match. Yeah, they do match. So what I typically try and have them do is to work with their partner and go through and see if they can match the correlation coefficient in the line with each scatter plot. So what I'd like for you to do now, if you're watching this, is pause the video and try and do this on your own, and then in a couple seconds I will put up the answers. Okay, obviously these should all be Y hat. That's the only typo. So see if you can try and do this on your own. Usually I'd have you talk with a buddy, and then I'll show you the answers. So here are the answers. I'm going to kind of explain them a little bit. So really what you should think about is looking at scatterplot 1, 2, 3 as their own and scatterplot 4, 5. Because 1, 2, 3, they're all positive. Let me try and do this. 1, 2, 3, they're all positive. So you're going to be working with A, C, and E. So with scatterplot number 1, it goes with just A. The R is 0.83. The line is very similar. And then scatterplot number 2, it's C, because this point is an influential point. So what this point does here is it increases your R value. So it makes your correlation stronger because it has a low residual. And then scatterplot number 3 is E. This point here is just considered an outlier. It's got a higher Y value than everybody else. So he actually makes the correlation weaker. Think about if you were to draw a circle around this, you'd have to include that point and it'd be much larger than in A. And then 4 and 5 are kind of similar because they're both in the negative direction. 4 is D, it's negative 0.83. And then 5 is B because again we have that outlier. So the R value is still going to be negative, but it's going to be much weaker. And then the last page is another you try. I typically have the students do. I make them put, it's the cost of textbooks for college bookstore price and then the online bookstore price. So I have them put them in their calculators, find the least squares regression line, interpret the slope, the correlation coefficient. Basically, A, B, and C, you should all be able to do for a quiz. And then we kind of go through D, E, and F together. So again, if you'd like to pause the video, you can pause and try and do this on your own. And then I'll put up the answers. But typically, I have them do that on their own. And then we kind of go through them. So for the first answer, you should get Y hat equals negative 3.7 or 57 plus 1.03x. X being the college bookstore price, Y being your predicted online price. Again, do not forget if you're going to write it like this, you need to define your variables. B, for every additional dollar in college bookstore price, we predict the online price to increase $1.03. C, R is 0.963. There's a strong positive linear relationship between college bookstore price and online price. Do any of these points appear influential? If you look at the scatter plot, no, none of the points have x values greater than or less than the others. So no, none of them are influential. In comparing prices of text, you might be more interested in the different line y equals x. What does it mean if it lies above the line, below it, or on it? So y equals x would be that the two bookstore prices are the same. So if your point is above the line, the online price is higher. If it's below the line, the bookstore price is higher. If it's on the line, they're the same price. And then we have them put the new physics book, see what it would cost online. So a lot of this, besides D and E, most of this you should be able to already do on a quiz or a test from 5.1 and 5.2. So that's it for 5.2 Day 2 with more correlation and more regression.